torque belt problems are a really common scenario in three-dimensional mechanics. And here's a little, we're going to analyze this obviously as a static situation, but imagine that inside your engine or some other industrial application you wanted to transmit a torque along a shaft. Often that torque is generated by a difference in forces on each side of a pulley. So we've talked about pulleys being the same on both sides. This is obviously in a scenario where it's not the same on both sides. Because you're putting a different force on that side of the pulley than you are on that side, you're trying to cause it to twist in that direction. And that's kind of the application we're looking at. In this case, we have some bearings supporting the shaft, and we want to make sure that they don't that the forces on there don't exceed their limits. We also have an unknown force here. We have a 50 Newton force on this side of that pulley and an unknown force here. So moment about an axis approach is the best way of looking at this. Again, it's as a scalar approach. That's what we were doing in the prior look as well. So what I'd like to do in this one is look down the shaft. Let's look down this shaft and view these things from the side view, and that's what I've done here. Let's say that this is the x-axis, and then this will be the y-axis and the z-axis going up like that. Let's go ahead and put the first two forces on here. Those are the 65 and the 55. Oh, I'm sorry, 65 and 80, looking down like that. Then off the larger pulley I have this unknown tension, and then up at an angle I have this 50 Newton force. And for our convenience and understanding and summing the moments, I'm going to put the components of that 50 Newton force. So in this case I'll have a 50 cos 45, and this will be 50 sine 45. I guess it doesn't say that in the picture. Oh, here it does say in the drawing right there. It says that the angle theta here is equal to 45 degrees. Alright, so what we're trying to do first of all is find out what this unknown torque is, or I'm sorry, that unknown tension is, and we can find out that from summing the moments about the x-axis. Again, we're doing that. So here's the x-axis, and I have this force pulling in this direction, this force pulling in this direction. So that's what this is all about. 65 going in the positive x-axis, 80 going in the negative x-axis. Each one of them has a lever arm of 80 millimeters. Then I have this torque here going in this direction. That's the positive direction, and that's got the unknown force. The lever arm is 150. That's the radius of the shaft. Then this one is going to be 50 times this lever arm. That's going in that direction. Now when you're solving these sine, cosine, these forces that are tangent to a pulley or tangent to a round thing, make sure that you don't try to break it up into its components to find out the tension. You'll just get confused when you do that, and it's not necessary. The lever arms are hard to figure out. So anyway, the torque or the force, let me just say the moment caused by a force and a radius is just the force times the radius. Anyway, that's where we got that. It's obviously going in that direction. I can solve that for the unknown force of T is 58. Alright, now what we're looking for is the components of reaction at the two journal bearings. So let's go ahead and draw those in here. And I'm going to again draw these things in their positive direction. So I'll say this is CY, CZ, and DY, and DZ, looking like that. The journal bearings, because they're journal bearings, there is no resistance in the x direction on either bearing, so I don't even need to put them in there. They'll just cause complication or confusion perhaps. So let's, if we want to find out the moment, or find out the reactions here, we will need to sum the moments about the axis. So let let's some moments about this axis first, the y-axis. In this case, D goes through y-axis. This is parallel to the y-axis. And this component is also parallel to the y-axis, which would be that component. Perpendicular to the y-axis are going to be these two forces trying to go in this direction. CZ is going in this direction, which is that way. And then this component, beg your pardon, this component of the torque, this 50-pound force or 50-Newton force is going up like that. It has a component in the, or moment about the y-axis. So just look at those carefully. We got 65 plus 80. This is going to be the lever arm, which is 0.45. Then I got 50, and this is the lever arm for the 50. And CZ has this lever arm. I beg your pardon, not this 50. It's just going to be this 50 sine 45, and it has that 200 lever arm, 0.2, and then CZ has this full lever arm. Anyway, then we can solve for CZ. Moment about the z-axis. D goes through Z. Reactions at D both go through the z-axis. This component of that 50 pounds is parallel to the 50 newtons is parallel to Z. These are both parallel to Z. This one's parallel to Z. So the only thing I have is that one and this component. And that's what I have a moment about the z-axis. I got this 50 plus 50 cosine, or sorry, this is 58 plus 50 cosine. It has both have the lever arm of that. And then CY has this big long lever arm. And then I can solve for CY, that's negative. Again, then similarly, summing the forces in the y is equal to 0, sum of the forces in the z is equal to 0, and I can get my final two reaction components. And that's really the process. Pick an axis about which to sum moments, solve for all the forces that you can, solve for all the reactions that you can, sum the forces in the x, y, and z, and you should get all of the things you need.